Alright, so today we're going to review distance, velocity, and acceleration, and I have chosen number 1 off your worksheet to go through and review. And the formula that you need to know that gives you like the basis of what you start with is S sub t, which stands for distance, is 1/2 gravity, it stands for gravity, t squared, plus the velocity initially, which is v sub t 0 times t, plus the initial position, or what height you're at when you start. And to write your equation for distance or position, you have to know all of the numbers that fill in your formula. To get your velocity or acceleration formulas, you do derivatives. So in this problem, a bullet is fired straight up in the air. Well, that's not really smart, but anyway, that's what they did. At a speed of 800 meters per second. So this is your initial velocity. This is how fast you shot it off. From a height of 2.4 meters, that is your initial height or distance or position from the ground. So when you go through a problem and you hear the word speed and you hear the word height, those are usually your initial values. Now what they did not give you is gravity, because they assume that you know it. And we have done quite a few problems with gravity on Earth in feet per second type measurements, in terms of gravity's acceleration due to gravity was negative 32 feet per second squared. We have not looked as much at meters. Does anybody know it? That's right. Negative 9.8 meters per second squared is gravity due to the metric system measurements. And so you have to know those two values. Any other gravity I'd give you, but I expect you to know the negative 32 feet per second squared, and I expect you to know this one when it's in metric. So the position formula, S sub t, is equal to half of this to put in front of t squared. So half of that's 4.9, is that right? I'm remembering that off the top of my head. I think that's right. Negative 4.9 t squared, because you always have to half this number to get the number in front of t squared, which is why when we do it with the other number, it's always negative 16. We're more familiar with that. And then you add 800, and I know it's add 800. Why? How do I know it's add, not subtract?
Because you're speeding up.
I shot it straight up in the air. I didn't shoot it down. I shot it up. If you shoot it up, it's going to be a positive velocity. Remember, velocity is a two-part thing. It's direction and speed. So if I shoot it up, it's going to be a positive direction. So that makes your velocity positive. If you shoot it down, it would be a negative velocity. And then you've got your original distance of 2.4 to go in for S sub 0. Now, the derivative of your position formula is your acceleration formula. Excuse me, your velocity formula. And the derivative of that, of course, will be acceleration as well. So once you do that, once you start taking derivatives, it starts changing it from distance to a rate. So if I put the 2 in front, that gives me negative 9.8 t plus 800. And what this shows me is that gravity speed in front of t, showing me what it's changing by, is decreasing, and that I started with a speed of 800. So there's actually a formula for that. Velocity is always gravity in front of t plus v sub 0. And then the second derivative of our problem is acceleration due to gravity. And of course, if we take the derivative of that, we actually get the gravity number because it becomes a constant. And that's what acceleration due to gravity is. It's negative 9.8.
Can I have your attention, please?
students scheduled to take the C.
All right, so now that we have our three formulas, as we read each question, we're going to try to figure out which formula would be the best one to set that equal to. So when it says, how long does it take for a bullet to hit the ground, do you think that relates to position or how fast you're going or acceleration? And usually it's going to be one of the first two formulas because the last formula is a constant. So should I be working with position when I want to know when I hit the ground? Or should I be working with how fast when I want to know when I hit the ground? Well, how fast does have something to do with it, but let me ask you this. Where are you when you hit the ground?
0.
Oh, 0. So, S sub t is going to be equal to 0 when you hit the ground. The velocity is not going to be 0, is it? But your position is going to be 0. So you want to take the first formula and set it equal to 0 and solve. Now, we know that if you just thought about a graph of this problem, if time was down here and position was over here, you started at a position and it goes up for a while until it comes back down and hits the ground. So we want this positive value this way over here. There wouldn't be but one positive value because you were already off the ground when you started. Usually these problems either have a negative and a positive answer in your calculator, or it'll have 0 and a positive answer when you start on the calculator, because you either started from the ground, which would mean at time 0 is 0, or you started at this height, and if I extended it back, it would be a negative time, which wouldn't make sense. Is that understandable? So when you set this problem equal to 0, sometimes when you look at the question, you might say, gosh, I think that might factor. And it might be quicker to just factor it, especially if you're working with the negative 16 in front. In this case, no. Because I've got decimals on both ends and a whole number in the middle. I don't think I want to multiply those two decimals together and try to figure out if it factors, because it probably doesn't. So in that case, that's where you might either do solver, or you might do this, y1, y2 on the graph. It just depends on which calculator you're using, which method you'd want to do. If you use solver on your 89s, it comes out a little quicker than doing the graph, because the graph you would have to figure out how to make it all show up. And what we're looking for is what time. So we're looking for how many seconds it takes from the time we shoot the bullet off till it actually comes back down and hits the ground, which is why back in those Wild Wild West movies, it wasn't really smart that people were going through town shooting their guns off, because eventually that bullet's got to come back down. They never show any of that in the movies because they're shooting blanks. But when you're doing this in real life, those bullets will come back down, and they will hit somebody if they're in the path of the bullet. So that's why it's very important to kind of know how long things take, especially if they were in a movie and they were actually using live ammunition. They would want to know, I need to be past this point at this time.
It gives me 2 answers. But always
The other one's negative?
yeah, one of them's negative.
Yeah, so we always need to throw the negative value away, because nothing in word problems is usually negative unless it's dealing with velocity. So what's the positive answer come out to be?
126.83.
Really? I would not have thought it would have been that high a number. Okay. Well, I thought I... Okay. Well, that might be right, because, we did... I was thinking it would take less time because we shot it off so fast. But we did shoot it off from not very far off the ground, so maybe that's why. And how much is that again?
163.2683.
268. 0.27. Anybody else getting that value? Chris, what are you getting that too? Okay. They're typing that right there in Solver. Uh-huh. Uh-huh. Well, if you type text, it's type a comma X. If you type T, it's type comma T. You sure you put your decimals in there? Okay. Are you sure y'all put your decimals in there? All right, so granted, that's a fairly large number, but it's still seconds, y'all. I mean, if I divided by 60, that wouldn't be that many minutes, would it? All right, so if we took this number, like, for example, and divided it by 60, how many minutes would that be? How much?
2 minutes.
2 minutes. Wow, that's a long time. So if you think about it, you know, the person who might come through that area later and get hit by it wouldn't even know a gun might have been shot off, because it takes 2 minutes and something. So that's why it's really not a good idea to just shoot guns off to be shooting guns off. All right, in our next one, we're looking at what are the maximum or minimum values. And I don't know why it says and, because it should say or. Well, maybe there's more than one. I don't know. We'll see. The velocity of the booklet. Do you think there's going to be a maximum or minimum velocity? Well, we shot it off at 800. What happens as it goes up?
Slows down.
Okay, then what does it eventually do? So it gets faster coming down. So there is a maximum and a minimum. Because when it's at the top, it's been slowing down, right? And then when it gets to the bottom, it's been speeding up. So let's talk about that more in detail. So when you think about that graph I just had, if the speed is 800 right here, let me not put that 800 right there. That's not a really good idea because that's not the distance. So when I shot it off at 2.4, it started at 800, and it slows down until it gets to the top. How fast is it going when it gets to the top? Now let's think this through. What has to happen for it to start going down?
Slows down.
To zero. So at the top up here, the velocity is equal to 0. That's a minimum. The minimum velocity is 0. When it hits the ground, it's doing the maximum velocity. So it's not hard to figure out what the minimum velocity is, because if it didn't stop kind of almost, I mean, it didn't stop long enough for us to notice it stopped, but if it didn't stop up there and have a 0 velocity, it wouldn't change direction and start coming back down. It's just continued to go up slightly, a lot slower. But then, when it starts coming back down, gravity starts speeding it up. So when you get down here to the bottom, you've got your maximum velocity. And that maximum velocity takes 2 calculations to figure it out. So that's why they first ask you to figure out when it hit the ground, because now we know when it happened. We just got to figure out how fast was it doing it when it happened. So when you take that number of seconds, t equals 163.27, that is the time in which your velocity is at its maximum. So that's why you want to figure out how long it took to hit the ground. And you plug that in your velocity formula, and it will tell you how fast was I going when I did that. So that's going to first compensate for the fact that I shot it off at 800, but multiplying that by the gravity factor is going to show what gravity did, and then by adding those two together, it's going to give me a final answer for how fast was it going when it hit.
It's so much faster. It's total 0.05 of a second faster.
Oh, really?
I did 0.07.
All right, so that came out to be how much? Point what?
0.046.
Point.
It's negative 800.0.
Oh, I'm sorry. I didn't get the first part. Negative 800.0, or there'll be 5. Well, I guess we should be given 3 decimal place answers. I didn't even think about that. Well, time is always 2, but this one we should be doing 3. 4, 6. Feet, no, not feet, meters per second. All right, so what does that negative tell us?
It's going down.
It's going down. So it's falling at 800.046 meters per second. So basically what happened was when it stopped up there at the top and had a minimum velocity of 0, it didn't make it back to what it was originally with just a hair more. All right. Now, another thing they could ask you to do is to find out the velocity at some particular time, any time. They could ask you to figure out what the position is at that time. So that's a clue word. When they tell you the word velocity or they tell you the word position or distance, that tells you which formula to use. And so in this problem, we're just finding V sub 60 because we want to know after a minute, after 60 seconds or a minute, how fast is it going. They'll give us a chance to see is it on the way up or on the way down because the velocity will come out positive or negative and we'll know which time factor that happened in relates to our curve. So if we put the 60 in, if it comes out positive, that means it happened on the way up to the top. And if it comes out negative, that means it happened on the way down with gravity. It's positive? Okay, positive what? Oh, just 212 meters per second. So, oh, that's because there's a 0 on the end. It gets rid of the decimals. 212 meters per second tells me that on the way up, after 1 minute, it has slowed down to 212 meters per second from the 800 it started at, but I know it's on the way up because it came out positive. So it's rising at 212 meters per second. So when you interpret it, and on the AP test, you might have to write a sentence sometimes explaining your answer. And that's why I'm kind of taking it in the negative out of the factor and putting in what it means or to be positive or negative, because that would be part of your sentence structure. Because you would go back and you'd reiterate that after 60 seconds, the velocity of the bullet is rising at 212 meters per second. So we can find out what it's doing when it hits the ground. We can find out what it's doing at any given time before then by just knowing a number to plug in. And then which direction is the bullet traveling in 60 seconds? We already know the answer to that because we just found out the answer to the velocity. So it's going up. So just write that. It's going up. Or on the way up. So there are a lot of things I can do. I can set the original problem equal to 0 for the position to find out when did it hit the ground. I can set the I need to go back and talk about something else. I will here in just a second. I can find out what direction it's going at any given time by just plugging it into velocity formula. So let's go back here for a minute. All right, so on this formula, we figured out how long it takes for the bullet to hit the ground because S was 0. Now in this problem, we've gone in and we found the maximum, but we didn't figure out this one yet. So let's go back and figure out the second part of this question on part C. Now that we know how to do the maximum and we know how to fill in some time and find any velocity, let's figure out when was the velocity 0. Now for the velocity to be 0, that means that the bullet has had to really stop traveling up, and for just a microsecond, it stops in midair and starts to go back down. We need to know what time that happened. So if I know the velocity up here is 0, then I could set the velocity formula equal to 0 to find that. And I'm going to move this number here out of my way so I got room to write. So if you take the velocity formula, negative 9.8t plus 800, and set it equal to 0, basically you're just dividing 800 by 9.8, because if you move the 800 over, it'd be negative, right? And then the two negatives will cancel out. So you're just saying 800 divided by 9.8, and that'll tell you what time that velocity happens to happen at. Okay, 81.633. Okay, seconds. All right, so the key here is, what are the maximum and minimum values of velocity? There are quite a few things you can do with that. If you were going to put some sentences together for this, you could say that the minimum velocity is 0 at 81.633 seconds. You could say the maximum velocity of falling at 800.046 happened at the 163 point whatever it was that I erased. So there are a lot of things I could do that I could ask you to find. Not just knowing the velocity is 0 there, but when did that happen is sometimes one of the things they might ask you to do. So it's not just hitting the ground that we set equal to 0 for the position, but we also sometimes set velocity equal to 0 to find out when did it change directions. Because that would be the split second of when it changed from going up to down. Alright, so we know that at that 60 seconds it was going up because it had a positive velocity. Now we know why. Because it took 81 seconds before it started turning negative. Does that make sense? Alright, the last question, find the average velocity between 1 and 3, is different. These velocities we've been talking about up to this point are instantaneous velocities. Velocities that happen at one time. When you ask about velocity for 2 times, it's an average velocity, and all it is slope. And again, let me explain that formula. It's S sub t2 minus S sub t1 over t2 minus t1. It's the position you're at the second time minus the position you're at the first time divided by the 2 times subtracted. So it's just slope. But I need those 2 times worked out in the position formula in order to be able to fill this formula in. So the key here is I need S sub 1 and S sub 3 worked out so that I can calculate those 2 positions of where is it along the curve, and then I can fill this formula in because I already know that the bottom is 3 minus 1 because that's my 2 times. I don't know the position I'm at those 2 times, but I can find that. Alright, so if you put in 1 and the negative 4.9 times 1 squared plus 800 times 1 plus 2.4, what do you get? Because that'll be how many meters I've moved where I'm at, my position, like how many meters off the ground I am. And then you just can go back, and if you copy it down, you could change the 1s to 3s. Or sometimes, if you want to do more than one value at the same time, you could put curly braces and put 1, 3, and it would give in both places, and it would give you both answers at the same time.
For 1, it's 797.5.
797.5.
And then for 3, I got 2,358.
2,358.3. All right, 2,358.3 minus 797.5. Wow, it went way up. And again, these units are meters because we're finding the position using the gravity that's meters over seconds squared. So these are positions are measured in meters. So when we calculate this up, the average velocity between these two will be in meters per second, because the top units are meters and the bottom units are seconds. So our velocity has to be in meters per second, just like it was with the initial velocity. And so we're just dividing this by 2, so you could subtract it, and divide by 2 all at one time if you put parentheses around the top. Or you could do the top and then do the bottom, or you can do parentheses around the top and the bottom if you don't want to take the 3 minus 1 in your head. But average velocity, what that gives you is it takes every value kind of along the way between 1 and 3's velocities and kind of boils it down to this is about what it is. And it won't be exactly what it would be at the instantaneous velocity, because instantaneous velocity would have to be about what is it at 1. But this would be a lot more related to what happened between there. What are y'all getting? Okay. And this is probably one of the few calculations that I can say for sure students miss a lot because they think they need to do derivatives to get it. And it has nothing to do with derivatives. It has to do with regular or everyday slope.
So average velocity to go through derivatives.
Because you have 2 times. See, derivatives are all about having what is the answer at 1 time. When you have 2 times, you just do everyday slope. And this is something they actually put in table form sometimes on the AP test. They'll give you a table and they'll say, I want the velocity at 5. But there's no 5 on the table. But 5 might be between 2 numbers. Well, you can find the average velocity, and that'll be about what it would be. So instead of giving you 2 numbers to go between, they give you a table that you pick the 2 numbers out of the table and say, well, this is what the 5 would be because it's between 3 and 7. So like, for example, if I said, what's the velocity at 2, and you didn't have a formula, but you had a big long list of table, if I asked for the velocity at 2, if you knew 1 and 3, you could find the slope, and that'd be about what it is at 2. Which is one of the things that we'll go into probably a little bit later when we get into the next chapter, I think. Okay, so that's kind of just a rough review of what we've been doing. So keep in mind that as you go through, what I really want you to focus on is that your minimum velocity is at 0 at the top, so you set the velocity formula equal to 0 to get that. But your maximum happens when your position is equal to 0. You got to keep those 2 things separate, because a lot of times students try to always do the same thing, and it's not the same thing every time. You got to know what's 0 so you'll know which formula to set it equal to. And that's the trickiest part about anything. Everything else is pretty straightforward. All right, so you have your worksheet now you can work on, and if you get stuck, let me know.